Welcome to This Explainer. Today, we're diving into a massive, honestly incredibly common challenge in the manufacturing world, bridging the machine data gap. We're going to look at exactly how to extract that trapped, highly valuable data from legacy machines, and we'll see how two powerful tools, the MTConnect software standard and WAGO hardware, team up to make it all happen. If you've ever looked out at your shop floor and wondered, how do I actually get my older equipment talking to my modern dashboards? Well, you're definitely in the right place. Here's our roadmap for this journey. We'll cover the shop floor data gap, what MTConnect actually is, the adapter agent architecture, WAGO's data acquisition layer, and finally, we'll weigh MTConnect versus OPC UA.
All right, let's jump right into Section 1, the shop floor data gap.
Think about the sheer frustration on a legacy shop floor. Most of these machines are already generating the exact data a plant manager wants, right? We're talking cycle counts, run states, spindle speeds, fault codes, energy draw, the whole shebang. The intelligence is literally right there. But the problem? On older or standalone equipment, that data is totally trapped behind a closed controller. It's like putting your data in a cage. We call this dark data. It just sits there uselessly, with absolutely no path to your overall equipment effectiveness dashboard, your manufacturing execution system, or the cloud.
So that brings us to the million-dollar question. How do you get it out? Like, how do we physically and digitally extract this trapped data to actually make it actionable for your operations?
To answer that, let's move to Section 2. What is MTConnect?
Meet MTConnect. Established back in 2006 right out of the machine tool industry, this is an open, royalty-free standard for retrieving data from manufacturing equipment. The absolutely crucial point here is that it acts as a universal language. It gives completely disparate machines, so whether you're running a Haas, a Mazak, or some totally custom-built cell, a common vocabulary. Instead of forcing you to decipher a dozen proprietary interfaces, MTConnect structures all that manufacturing data as clean XML, and then just serves it over HTTP. It uses plain, everyday web technology, meaning any app that can make a standard web request can consume your machine data. It's a real game changer.
Now, one of the defining characteristics of MTConnect is this. You are listening, not commanding. It is entirely read-only and unidirectional. Data only flows from the machine up to the application. MTConnect does not write back, and it doesn't control the machine. This is a massive relief for plant operators, honestly, because it makes it inherently safe to deploy on active production equipment. You can monitor everything without the risk of accidentally altering a machine's programming or ruining a production run.
All right, moving right along to Section 3, the adapter agent architecture. This is how MTConnect actually functions behind the scenes.
Let's walk through this data journey step by step. MTConnect moves data through three distinct roles. Step 1 is the adapter. This sits right down closest to the machine. It reads raw signals like digital states or analog values and translates them from whatever proprietary format they're in into MTConnect's common terminology, usually spitting it out as a simple pipe-delimited text stream. Step 2 is the agent. The agent grabs that raw text stream from the adapter, structures it into valid, clean MTConnect XML, and serves it over HTTP to anything that asks for it. And finally, Step 3 is the application. This is your OEE dashboard, your MES, or your cloud analytics platform. It consumes the agent's data and turns those raw machine signals into the utilization reports and downtime tracking you actually use.
Now, understanding those three roles is the absolute key to understanding where physical hardware fits into the picture. So let's hit Section 4, WAGO's data acquisition layer. Here's the thing. On a standalone machine that exposes absolutely no native data, software alone just isn't going to cut it. WAGO's role in an MTConnect deployment is to act as the physical bridge. It's the layer that physically captures the machine's signals and provides the actual computing power to run that adapter and agent we just talked about. The reason this works so seamlessly is the architecture of WAGO's PFC controllers. Both the compact PFC 100 and the higher performance PFC 200 run a real-time capable embedded Linux operating system. And since the MTConnect agent source code is freely available for Linux, the agent function runs directly on the controller itself. Meanwhile, the adapter is implemented as a function block in Codesys, configured right through the controller's web-based management. Oh, and to make things incredibly easy, WAGO even offers a pre-configured MTConnect interface for the PFC 100, so you literally don't have to write the agent from scratch.
But how do we actually touch the machine? Well, we tap the signals with WAGO's modular 750 series Slice I/O. Think of these snap-on DIN rail modules as the physical ears listening to the machine. You've got the 750-430 module, which is an 8-channel digital input perfect for capturing run, idle, and fault states, or cycle pulses. Then there's the 750-467 analog input module for 0 to 10 volt sensor signals, and the 750-498 thermocouple input module to keep an eye on process and motor temperatures. These just snap right onto the same node as the controller, feeding those physical signals directly into the MTConnect data stream.
But tapping signals definitely goes beyond just basic machine states. We absolutely can't forget about energy. WAGO's power measurement modules can handle up to 690 volts AC. These things are absolute beasts. The 750-494 and 750-495 modules capture line-to-line voltage, current, real and reactive power, power factor, you name it, and they feed it all right into that exact same MTConnect stream alongside your cycle counts.
Now, you might be wondering, why does capturing that energy data matter so much? Well, because energy isn't just about utility costs. A rising power draw often signals a developing mechanical problem. By feeding this power data into your dashboards, you're enabling true predictive maintenance. You can catch an abnormal power draw and identify a mechanical fault way before the machine breaks down and causes expensive, unexpected downtime. Okay, let's transition to Section 5 and address the elephant in the room, MTConnect versus OPC UA.
This is usually the biggest question integrators have, so let's impartially compare the two standards. MTConnect, as we just learned, is strictly read-only for monitoring. It originated in machine tools, is highly favored here in North America, and it's perfect for OEE and downtime monitoring. OPC UA, on the other hand, is bidirectional, meaning it can both read and write. It originated over in process automation, is highly preferred in Europe, and is best when you need closed-loop control and broad device interoperability. So if your goal is purely to monitor uptime and throughput safely, MTConnect is generally the lighter, safer choice. But if you need to integrate at the control layer and write commands back to the machine, OPC UA is your tool.
But hey, here's the really great news. They aren't enemies. A growing number of plants actually run both. A companion specification formally bridges MTConnect and OPC UA so they can work together seamlessly. The practical takeaway here is that you want hardware that won't lock you into just one path. The WAGO PFC 200 controllers, for instance, speak MQTT and OPC UA in addition to hosting an MTConnect agent. Basically, one hardware platform covers your monitoring today and your control layer integration tomorrow.
So how do you actually get started turning your legacy machines into data sources? A very practical next step is to work with an authorized expert like Automation Distribution to match the right WAGO gear to your unique equipment. You can reach out to them at 1-888-600-3080 to help scope your specific project. They'll make sure you get the exact PFC controllers and 750 series I/O that fit your machine's signals perfectly.
We've covered a lot of ground in this explainer today, from the pure frustration of dark data to the elegance of MTConnect, and finally the physical bridging power of WAGO hardware. I want to leave you with this final provocative thought. As you look across your own shop floor right now, are your machines acting as isolated islands holding on to their secrets, or are they active data sources driving your operations forward? The tools definitely exist to bridge the gap. The next step is up to you. Thanks for joining me, and keep learning.